Welcome students. Here we are discussing an interesting question from the chapter binary operations. Here question is, let A be a set having elements 1 minus 1 I minus I be the set of fourth roots of unity. Prepare the composition table for multiplication on A and show that first A is closed for multiplication, second multiplication is associative on A, third multiplication is commutative on A, fourth 1 is the multiplicative identity, and fifth every element in A has its multiplicative inverse. Okay, so let us see the solution here. Here set A is having elements. These are fourth root of unity. These are 1, minus 1, I and minus I. Now we have to form a composition table. Let us form composition table. Composition table with respect to multiplication. So in first row and first column we have to take these elements 1 minus 1 I minus I, 1 minus 1 I and minus I, and in this first column we will write these elements 1 minus 1 I and minus I. Here we will write multiplication as the operation. So 1 into all these elements will remain same. So 1 into 1 is 1, 1 into minus 1 is minus 1, 1 into I is I, and 1 into minus I is minus I. Now multiplying all these elements with minus 1, we will get here minus 1 plus 1 minus I and plus I. Now multiplying these elements with I into 1 is I into minus 1 is minus I into I, that is I square is minus 1, and I into minus I is minus of I square, that is plus 1. Now multiplying these elements with minus I into 1 is minus I into minus 1 is plus I into I is minus of I square. You know I square is minus 1, so minus of minus 1 is plus 1, and minus I into minus I, that is I square is equal to minus 1. So this is composition table. Clear? Now next we have to show multiplication is associative. This is first. Now second we have to show associative. For showing associative we can take any 3 elements of this 4. So let us take 1 minus 1 and I. So 1 into minus 1 into I. This is equal to 1 into minus 1 is minus 1. So this is minus 1 into I, and this is equal to minus I. And now we'll make a pair of minus 1 and I. So 1 into minus 1 into I. This is equal to 1 into minus 1 into I is minus I, and 1 into minus I is equal to minus I. So here we are showing that first 2 elements in the bracket, here last 2 elements in the bracket, and both are equal, hence associative. Associative. Next, third, we have to find multiplication is commutative on A. We have to show that multiplication is commutative on A. One thing we are missing, this first. A is closed for multiplication. So since all elements inside this table are from set A, so this operation multiplication is closed in this set. Okay, since in this composition table all elements are coming from this set A. Okay, so before coming to this point 3, we have to write the statement for part 1. So as all elements of the composition table are from set A, therefore set A is closed. Therefore set A is closed with respect to multiplication. Now let us come to third. Third is multiplication is commutative. Simply here we have to write the statement that first row is coinciding with the first column, second row is coinciding with the second column, third row is coinciding with the third column, and fourth row coinciding with the fourth column. So this set A is commutative with respect to this operation of multiplication. So as all the rows of composition table coincide with the corresponding rows therefore set A is commutative with respect to the operation of multiplication. Now fourth part is we have to show that 1 is the multiplicative identity. So you see, when all these 4 elements are multiplied with 1, we are getting the same number, 1 minus 1 I minus I. So 1 is multiplicative identity. So as 1 into 1 is 1, 1 into minus 1 is minus 1, 1 into I is I, and 1 into minus I is minus I. It means that is 1 is the identity. Now fifth, every element in A has its multiplicative inverse. So you know that if two elements A and B are multiplicative inverse of each other, then A operation B is equal to identity element. Okay, this is the condition for being inverse of the element. So here 1 into 1 is 1, so inverse of 1 is 1, that is inverse of 1 is 1. Again minus 1 into minus 1 is equal to 1, so minus 1 is the inverse of minus 1. That is, minus 1 is the inverse of minus 1. Next, I into minus I is equal to 1. I into minus I is minus I square, and I square is minus 1. So minus of minus 1 is plus 1. That is inverse of I is equal to minus I, and inverse of minus I is equal to I. So we have proved all these conditions here. Solution is very interesting, very important. Hope you have understood it. So if you are enjoying these videos, your likes are most welcome, and share these videos with your friends also. If you want any clarification, or you have any confusion, or you want to give any suggestion, please write in the comment box. Wish you all the best.